Welcome to Olive Tree Lab Terrain Tutorials. In this video we are going to focus on the calculations and the use of the results graphs panel as well as the excess noise level bar. Let's start by opening ISE's standard configuration. Calculations in terrain are based on sound ray paths. The process is divided into two parts that combined produce the final calculation results. The first part is predicting the paths between the source and the receiver. This gives the user an indication of the route the sound is going to make to reach the point of interest, where the receiver is located. The second part uses those paths and calculates the effect on sound reaching the receiver, taking into account diffractions and reflections on objects. This is the Show All Paths function I clicked a few seconds ago. It predicts and displays inside the geometry viewer all possible paths between source and receiver depending on the method chosen in the calculation options. Double-clicking on a path opens the Paths Explorer, where you can see information about the distance, reflection and diffraction order of each individual path. The button next to it is the Show Paths to be Calculated function. This will only display the paths to be calculated according to the number of strongest paths set in the calculation options. Here, as you can see, the number is restricted to 8. The next two buttons do exactly the same, with the difference that the paths predicted disregard the existence of the noise barrier entities as implied by the button's icons. Let's proceed and run a precise calculation. With the calculation process completed, paths that are taken into account are displayed inside the geometry viewer, and the results are plotted both in the results graph under the Precise Results tab, as well as in the output window that emerged a few seconds ago, that you can view under the View menu output window. The output window will be shown in a later video. Here a total of 5 curves are displayed in octave bands. Those are the noise criteria that can be set through the receiver panel, the level before and after are the actual level of the source reaching the receiver before and after the effects of the barrier, the insertion loss that shows the efficiency of the barrier under the specific circumstances, and finally the excess level is how much attenuation is needed to meet the noise criteria. Here you see the level after is inside the noise criteria region, and thus the excess level is 0. The results are also in a tabular form with copy functions to export. Now, apart from the precise calculation, there is a function that is conducting indicative calculations. The difference is that it uses only barriers, grounds, sources and receivers, disregarding wall surfaces. Clicking on the Run Indicative Calculation opens the results graphs under the indicative graphs. Let's open it a bit more to have a better view. The benefit of the indicative calculations is the speed. For instance, if I move using M on the keyboard to move the barrier, and then click again on indicative calculations, you get results much faster. Now if I click the real-time update on indicative graph, this change will be made instantly. So again, if I move the barrier using the arrows, you can see that the indicative graph is updating in real time. You may have noticed this bar on the right hand side of the screen. This is the excess noise level bar. It gives you an indication of the current situation without the need to have the results graph in view. Like in this case, where the barrier has no effect in attenuating the sound, it reaches the red color. Yellow means you are marginally inside the noise criteria, and green that you have solved the noise problem. Thank you for watching this video.